Alright, in this lesson, we have been asked to find the limits of the function e to the sine x minus 1 all over x, and we have been asked to turn x to 0. So what do we do first here? The first thing we do here is, as usual, is test our value 0. So let's test the value 0 and see what it gives us. So we have limit as x tends to 0 of e to the sine x minus 1 all over x is equal to, at x as 0, so we have e to the sine 0 minus 1 all over 0. So this gives us sine 0 is obviously 0, so we have e to the 0 minus 1 all over 0. E to the 0 is 1. 1 minus 1 is 0, so we have 0 all over 0 as a result. So which means that we have, here we get the indeterminate form, and whenever we have this, we should search for other alternative, and one of the alternatives is the L'Hopital's rule and also the Taylor series expansion method. But in this video as well, I would like to use both methods for you, so at least you see the clarity of the question and you see how we can link and Taylor series and L'Hopital's rule so we can get the same result. So first of all, here we use the Taylor series expansion method for this question. So using the Taylor series expansion method. Now we know that the Taylor series expansion for sine x is x minus where these signs are alternating. So we have x minus x cubed over 6 plus x5 all over 120 minus that. Now this is the Taylor series expansion for sine x around 0. So now if this is Taylor series for sine around 0, so we have to assume, in this case, we have to assume that this sine x is equal to whatever variable you like, whatever variable that. So in my case, I would like to use variable m. So let's say this sine x is equal to m. So if sine x equals m, this man here becomes e to the m, and the Taylor series expansion for e to any variable, I will say that again, the Taylor series expansion for e to any variable is equal to 1 plus the variable squared over 2 factorial plus the variable cube all over 3 factorial. Actually, there is a 1 factorial here, but it means nothing. Here, the signs are not alternating, but for the sign, the signs are alternating. Now, the next thing we do here is this. Now, since we know that m is equal to sine x and e to the m is this expansion, all we have to do here is solve for m. Wherever you see m in this function, put sine x in that function. Okay, let's put sine x in that function. So e to the sine x is equal to 1 plus sine x all over 1 plus sine squared x all over 2 factorial plus sine cube x all over 3 factorial plus that. So I believe to this point you are clear and not lost. So now we are at this point, and I believe you are making good progress. So now what do we do at this point? All we have to do at this point is just see, we are here, but we are arriving here. We are here, but we are meant to arrive here. So what do we do here is, from the function we take away 1, but we know that this will also go to 0. But let's do that. Let's take away 1 from that function and see what this man gives us, because we have to arrive here at the question from this place. So let's go. So we have e to the sine x minus 1. Because I remove 1 here, I have to do so here so I don't alter the system. So we have 1 plus sine x plus sine squared x all over 2 factorial plus sine cube x all over 3 factorial. Now we are subtracting 1. We are subtracting 1. So obviously this one will take away this one, and we are left with this function e to the sine x minus 1 is equal to sine x plus sine squared x all over 2 factorial plus sine cube x all over 3 factorial. This is our result after simplifying e to the sine x minus 1. So what else are we supposed to do? We are at this point now, e to the sine x minus 1, and we are supposed to be here. So all we have to do here is just what? Divide both sides by x. Divide both sides by x. So we are dividing both sides by x now. Both sides by x, so we can arrive at our question. So dividing both sides by x will bring us to our question itself. So we can say e to the sine x minus 1 all over x is equal to, by separating this we have sine x all over x plus sine squared x all over 2x plus sine cube x all over 3x and the factorial. So that's what we have now after introducing the x. So now at this point, all we have to do is find our limit as x approaches 0 and see what we get. So let's do that. So we have e to the sine x. So we have e to the sine x minus 1 all over x is equal to sine x all over x plus sine squared x all over 2x plus sine cube x all over 3x squared, all over 3x factorial. This is what we have. I just happen to bring it back. This is what we have. So we have this. We have this. So now let us apply limit to both sides and see what we get. So the limit as x approaches 0 of e to the sine x minus 1 all over x is equal to the limit as x approaches 0 of the entire function sine x all over x plus sine square x all over 2x plus sine cube x all over 3x, 3 factorial x. That is actually 6 if you like. So now let's apply our 0. So the limit as x approaches 0 of e to the sine x minus 1 all over sine x is equal to, now we know, let's apply the limit independently. So we have limit as x goes to 0 of the first one, sine x all over x, plus the limit as x goes to 0 of the second function, sine squared x all over 2x, plus the limit as x goes to 0 of the third function, sine cube x all over 6x. All over 6x. All over 6x. So now we know that the limit for this function is equal to 1, but the limit for this function goes to 0. This also goes to 0. How? I'll show you. So the limit as x goes to 0 of e to the sine x minus 1 all over x is equal to, we know this, right? Our regular limit. This goes to 1 plus this to 0 I said. Now let me show you how. Now let's imagine that we have this. This is sine x by sine x. Imagine that one of these sine x is having the 2x. Let's imagine this. Let's imagine this. And don't forget that we are applying limit to this man here. Now plus the third. The third one says limit as s goes to 0. Just pay attention. Third one says sine x, sine x, sine x. Now I will imagine one of these sine x is having this 6x. So 6x here. Okay. I'm about to show you how this man goes to 0. So we have limit as x goes to 0 of e to the sine x minus 1 all over x is equal to 1 plus sine x all over x is 1. But if I place 0 here, sine 0 is 0. 0 multiplied by this goes to 0. Sine 0 is 0. Sine 0 is 0. Although this is 1 over 6, but 1 over 6 times 0 goes to 0. So we can conclude that the limit, sorry, let me make this clean. We can conclude that the limit as x tends to 0 of e to the sine x minus 1 all over x is equal to 1 by the Taylor series expansion method. Now, let us use the L'Hopital's rule to also determine this function. Now, using the L'Hopital's rule. L'Hopital's rule. And L'Hopital's rule says that we should apply derivative to each component part of that function. Each component part of the function. So derivative that depends on x, on whatever variable you have, on the limit as x goes to 0 of e to the sine x minus 1 all over x will be the derivative as that depends on x on the first one. On the first one, e to the sine x minus 1 all over the second one. The second one, which is the x. So all right. So if we apply this derivative, we know that if you, okay, let's make sure this is clean. It's clean. All right. So the limit as x tends to 0 of e to the sine x minus 1 all over x is equal to, now let's differentiate e to the sine x. So if you have a function that says y is equal to e to the power of x, to differentiate this, the formula is simply e to the u multiplied by u prime. That's the formula, where u is whatever it is that you find at the top of that constant. Yes, of that constant at the top here. So in this case, our u is equal to x. U prime is the derivative of u, which gives us 1. So the answer to this value, the y all over the x of this function, is equal to, I said, e to the u times u prime, which is still e to the x. So when you differentiate e to the x, you still get e to the x. So in this case, we are defining e to the sine x, which means that in this case, our u is sine x. Our u prime is cosine x, which means that our dy dx is equal to u prime cosine, e to the u, that is e to the sine x multiplied by u prime cosine x. So this is what we get here. So when we differentiate e to sine x, we get e to the sine x e to the sine x multiplied by cosine x. Now 1 goes to 0, all over x goes to 1. So this is all over 1, which is still e to the sine x multiplied by cosine x. At this point, we can apply our limit. So the limit as x tends to 0 of this function now, this one now, is equal to e to the sine x dot cosine x equals e to the sine of 0 multiplied by cosine of 0. And we know that sine of 0 is 0. So we have e to the 0 dot cosine of 0. E to the 0 is 1. Cosine 0 is 1. 1 times 1 is 1. So using L'Hopital's rule, the limit as x goes to 0 of e to the sine x minus 1 all over x is also equal to 1. So thank you and see you in the next lesson.